Tutorial number 4. A plate of negligible weight closes a 0.3 meter diameter hole in a tank containing air and water as shown in figure 10. A block of concrete, specific weight 15,000 Newton per meter cube, having a volume of 0.5 meter cube is suspended from the plate and is completely immersed in the water. As the air pressure is increased, the differential reading delta H on the inclined tube mercury manometer increases. Determine delta H just before the plate starts to lift off the hole. The weight of the air has a negligible effect on the manometer reading. So this is the situation. So we have an air source pressure here. So a pressurized air being put here. So and then the pressure inside this chamber will increase. So and then the pressure from the air will push this plate, okay, and at certain amount of pressure, so it will open the plate. So at the same time, the same pressure will push the mercury here. So and then it will give the increment of mercury like this one. So and this is the open-ended, so means that here the PATM occur. So we need to calculate what is the pressure just before the plate lift. So we could draw a free body diagram based on this situation. So we focus on this block. So we have a block here fully submerged in water, and for sure the weight of the block is exists. So and then because it submerged in water, so the force of buoyancy will exist. So and then we need to add an extra force here because there is a pressure for this air, and this pressure will act on this plate and it will create force because we have pressure and it acts on certain surface area here. So F is equal to pressure times A, so it will create force. So at certain amount of pressure, it will lift the plate here, so means it will move out upward like this one. So in free body diagram, we add an extra force here, so that works upward. So the equilibrium we could write as this one: weight is equal to force of buoyancy plus PA. So and then we substitute all the value here. We could find that the pressure is equal to 26.7 kilopascal. So and then we know that the pressure that acts here is 26.7 kilopascal, so means that the same amount of pressure will act on the surface. And then we draw a line here, and then according to Pascal paradox, the pressure at here is same with the pressure at this one. So and then we could calculate the pressure of this one by using the rho GH plus the PATM here. However, PATM will equal to 0. So we could calculate as this one. It is rho GH with the rho of mercury here, the density of mercury, and the H is in vertical direction. So we could calculate that the H here is 2.04 times 10 to the power of 10 meters.